Okay, so welcome back to this video in which we are discussing why nicotine is addictive. Okay, so we're continuing our discussion of neuroanatomy. Right, so that we can find and understand where the nucleus accumbens is. So, this portion medially, this is what's known as the globus. Oh god, what have I done? Well, I'll turn that into a G, an L and an O, but it was a B. There we go, globus pallidus. Don't worry, I'll write globus out many times again. So this is globus pallidus. The whole thing is the globus pallidus. But you divide it into two portions. So the globus pallidus is divided into two portions. Now, the external portion, the portion closer to the putamen, is what's known as the external globus pallidus. So I am going to write globus again. External globus pallidus, that's better. Alright, so we'll colour in the external globus pallidus in red, I think. And the other portion of the globus pallidus, the portion that's more medial and is closer to the thalamus, which we'll colour in purple here, okay, that's known as the internal globus pallidus, and the same is true on this side here. Okay, so this is the internal globus pallidus. Now, these structures are not relevant for the mesolimbic dopamine pathway. However, I'm showing you them so that we can understand the position of the nucleus accumbens. Right, so we've now done these lenticular nuclei, which are the combination of the putamen with both of the external and internal globus pallidus is. Okay, now let's draw another picture where we're again looking at this sort of an image, i.e. we're looking from the side rather than above. So here we're looking from above. Let's draw another picture where we're looking from the side now. Okay, so basically, where should I draw this? I need a lot of space for this. So here, let's say this is the putamen. So we are looking now at the putamen here. So this is this same structure, but we're now looking from this side here. Okay, so from the outside, this is the structure of the putamen, okay, and it's in front of the thalamus now because we are looking from the side. So the thalamus will be this little structure sort of peeping out from both sides, and then underneath you'll have the midbrain on which the thalamus is sitting, okay. So we're still looking from the left-hand side, so let's colour in these structures. And now I'm going to show you the structure which joins on to the putamen, and this is where we're going to see the nucleus accumbens. Okay, and I don't think I will colour in the thalamus, at least not yet. So basically there is a large structure that joins on to the putamen on this anterior aspect. So basically joining on here, okay, there is a huge great structure that's going to come round and down. So let me show you this. So here comes this massive great structure. Okay, right, so let me complete it like so. Okay, so you have this sort of huge great brain structure here that joins on at the front of the putamen and comes completely around. Now I'm going to convert this into two separate structures. So let me highlight these bits in separate colours. So in bright purple here, we've got this bit down here, okay? And then I need another colour that's going to show up. I'll have to use my turquoise colour. So, in turquoise, we then have the rest of this massive great loop structure here, continuing on down here. Okay, now, this entire structure, okay, this entire structure where you have the caudate nucleus, oh, I haven't told you that, that's what it's called yet. This entire structure where you have this great big green thing, this great big turquoise thing that I'm drawing or outlining here now, which is called the caudate nucleus. So in turquoise, this is the caudate nucleus that attaches on and loops around the putamen like this. So this is the caudate nucleus. Okay? The combination of this turquoise caudate nucleus and the putamen and this pink thing, which is what we've been looking for, this is the nucleus accumbens down here. The combination of all three is what's known as the striatum. Okay, so they are all referred to as the striatum. Now, the nucleus accumbens is often specifically referred to as the ventral striatum. So if you hear people talk about the ventral striatum, they mean generally the nucleus accumbens. Okay, right. So, I hope you understand where this thing is. It's sticking off from the side of the lenticular nucleus, and it's coming all the way around and forming a great loop that then spirals back underneath this. So I hope that me drawing both of these pictures, you can now put them together. This is it from the above, then we've got this thing happening on the side, basically. So these, you've got one of these on each side, not just on the left side. You'll have one here, and you'll have another caudate nucleus on this side. So again, you have two nucleus accumbenses, one on each side as well. Okay, right. So, what happens is that the ventral tegmental area is going to send neurons to the nucleus accumbens, okay, here. So we can see the midbrain in our picture here. Here's the midbrain. Now, in front of the midbrain, there is a structure known as the hypothalamus. Okay, so I might draw this sort of like here. So here's the hypothalamus, and it has the pituitary gland coming off the bottom. And I wish I hadn't drawn the nucleus accumbens name there now. I think I'll try and draw this picture again, because I think it'll be worth it. Okay, so let's draw that picture again so that I can show the hypothalamus, because the neurons that are coming from the ventral tegmental area and going to the nucleus accumbens, they are going to go through the hypothalamus in what's known as the medial forebrain bundle. So I want to show you where the medial forebrain bundle is. Okay, so let's draw this picture again. So what did we have? We had the midbrain here. Okay, so this is the midbrain. Then we had the thalamus sitting on top, but firstly we need to draw the putamen seen from the left-hand side. So remember, this is in a plane in front of the midbrain. It's not sitting on top of the midbrain. It's closer to us than the midbrain is. The thalamus, which is behind this putamen, is sitting on top of the midbrain. Okay, and then what you've got is this. I don't think I'll show the thalamus because it's not terribly relevant for our discussion of the mesolimbic dopamine system. Okay, we've got this structure coming round like this, which at the bottom is the nucleus accumbens here, and then the rest of it is the caudate nucleus. Okay, coming round in this great spiral like so. Okay, so there's the caudate nucleus. So let's colour these portions in. And this time, since I'm not showing the thalamus, I think I'll draw the nucleus accumbens in orange here. So this little nucleus at the bottom here, this is the nucleus accumbens. And by the way, the nucleus accumbens is often abbreviated to NAC. So don't confuse this for some abbreviation of nicotinic acetylcholine receptor. This means nucleus accumbens. And people also refer to this as accumbens nucleus. I think this is the more sort of Latinic, if you like, if that's even a word. It's more Latiny, so the old boys will probably refer to it as the accumbens nucleus. But nowadays it's called the nucleus accumbens. Right, okay. Now let's have the caudate nucleus shown. Okay, so here's the caudate nucleus in this bright green colour. Now this is not relevant for what we're discussing, it's just so that you can understand the neuroanatomy at the same time. Okay, this again is very important in the motor system. Okay, it's important in the nigrostriatal dopamine system rather than the mesolimbic dopamine system. Okay, so this is the caudate nucleus. Okay, and then the structure that they're all connecting to here, this is the putamen, which we'll have in this blue colour here. So this is the putamen here, which, remember, as I say, is in all of these structures that I've coloured in now, they are in a separate plane to the midbrain. The midbrain is further back than them because they are sitting lateral to the thalamus, and the thalamus is sitting on top of the midbrain. Okay, so this is the putamen. Again, the putamen isn't important for the mesolimbic dopamine system. It's important in the motor system. Now, and I've just realised I've put that label exactly where I want to draw the hypothalamus again. Okay, never mind, I'm just going to have to squeeze it in here. So sitting here, you have this structure known as the hypothalamus, okay, and here's the pituitary stalk leading to the pituitary gland, which I've drawn really dodgily. And then you have the optic nerve there, and it will go up like that. Okay, so let me outline this structure. Okay, we'll have this structure in, what colour should we do? Vivid purple. So in vivid purple, to show up here, this is the hypothalamus here with the pituitary glands dangling down from it. Okay, so there are different bits of the hypothalamus. So these lumps that you have two of these, a left one and a right one. We are obviously only seeing it from the side, so we're only seeing one of them, but there will be two of them. These are known as the mammillary bodies. And despite their name, they're not involved in lactation. They're actually very important in memory. Mammillary bodies. Okay. This is the pituitary gland here. And then above here, all of this structure above the pituitary glands, all of this is the hypothalamus. Okay. So let me just label it up as the hypothalamus. So this is the hypothalamus because it's sort of below the thalamus. The thalamus is up here. Okay, so this is the hypothalamus. Okay, so hypo means below, and thalamus is the thalamus. Okay, and this bit at the front, I'll just label this as well. This is where the optic chiasm would be. So this is the optic chiasm. Okay, right. So, and then pituitary gland is pretty recognizable. Okay, so the ventral tegmental area will be somewhere here. Okay. Actually, it will probably be somewhere further back than that, but never mind. We've done it now. So what it's going to do is it's going to send neurons forward into the nucleus accumbens, like so. And it will send them in both directions. So we're only seeing the left-hand side at the moment. It will do this for the right-hand side as well. So there will be two bundles of fibres, basically. One on the left side going to the left nucleus accumbens, and the same thing will happen on the right side, basically. Okay, so it's sending these fibres to the nucleus accumbens here, and this anatomical bundle of fibres here, which I will highlight in pink. So this bundle of fibres here, this is what's known as the medial forebrain bundle. Okay, so these fibres travel in what's known as the medial forebrain bundle into the nucleus accumbens. Medial forebrain bundle. And the medial forebrain bundle is often abbreviated to MFB for short, medial forebrain bundle. Okay, so basically, all of this discussion was to get to this picture. Here is the ventral tegmental area, the VTA. Here is the nucleus accumbens, and connecting them is this medial forebrain bundle. So, the ventral tegmental area sends out axons which are going into the nucleus accumbens. Okay, now, when the ventral tegmental area neurons become active, their axons are going to fire action potentials, and the axon terminals in the nucleus accumbens are going to release neurotransmitter. Now, what neurotransmitter do they release? Well, what is this entire system called? The mesolimbic dopamine system. Okay, so let me write this down somewhere. Mesolimbic dopamine system. And by the way, that's what this whole thing is called. This ventral tegmental area connected to the nucleus accumbens. This is the mesolimbic dopamine system, or just the mesolimbic system. And basically, what's happening is these ventral tegmental area neurons are going to release the neurotransmitter dopamine. Okay, so let me just talk through what the structure of dopamine is. So the structure of the neurotransmitter dopamine is as follows. It's very similar to the structure of noradrenaline. It's very close to the structure of noradrenaline, in fact. Okay, so let me show you this. So the structure of dopamine is basically noradrenaline just with one fewer hydroxyl group. So you have the amino group, then you have an ethyl group here, like so, and then you have a benzene ring here, okay, and then off this benzene ring you have these two alcohol groups, like so. Now this is the structure of dopamine. To turn this into noradrenaline, or norepinephrine as the Americans call it, all you have to do is take one of these hydrogens off and put an alcohol group there instead. So it's very closely related to noradrenaline. It's part of the synthesis pathway for noradrenaline. Right, so the ventral tegmental area, when it becomes excited, it releases dopamine into the nucleus accumbens. So what? Okay, so why do we think this is important? Well, basically, this is our neurological model. Well, this is what we believe underlies positive reinforcement. So, basically, when you do a behavior, such as Toby coming when I call his name, and you get a reward, what the reward does, okay, what the reward leads to, is it leads to the ventral tegmental area releasing dopamine, which by the way is often abbreviated to DA, into the nucleus accumbens, okay? NAC, I'll abbreviate that too, and for some reason I forgot to put lowercase n there. It should be lowercase though, to be strictly correct. Okay, so reward causes activation of the ventral tegmental area neurons. Those fire and release dopamine into the nucleus accumbens. When you release dopamine into the nucleus accumbens, that leads to positive reinforcement of whatever behavior you were doing when the dopamine surge happened, i.e. it will lead to an increase in the frequency or vigor of that behavior. So it will make you do the behavior more, in simple English. Okay, that's what positive reinforcement of a behavior means. It means you will do that behavior more. Toby will come when I call him more. So the dopamine going into the nucleus accumbens, we don't know how. Don't ask me how. But we believe that underlies the neural modifications that are needed to positively reinforce the behavior, basically. So this is the natural reward system. Okay, this is how you upregulate your behavior when the behavior provides a reward. Okay, so to repeat it one last time because it's worth repeating, if Toby comes when I call him, firstly it'll just be spontaneous. If he just happens to come when I call him, I'll give him a reward. His ventral tegmental area will fire, it will release dopamine into the nucleus accumbens. That will lead to modifications of the brain such that the behavior that was that he showed nearby the spike in dopamine levels in the nucleus accumbens is going to be positively reinforced, i.e. he will do that behavior more. So there will be neurological changes that lead to him doing the behavior more. Okay, right, and basically the way that nicotine is going to work to trigger addiction is that on these ventral tegmental area neurons, we have nicotinic acetylcholine receptors of the alpha 7-5 homopentamer type. So, when you smoke, nicotine is inhaled, well, nicotine is in the cigarette smoke, okay? And you're going to inhale that into your lungs, and then it just goes across the alveolar walls into the blood. It's then going to go around the circulatory system up to your brain, and it's going to cross the blood-brain barrier. It will then go and bind to these nicotinic acetylcholine receptors that are on the ventral tegmental area neurons in the ventral tegmental area. So the cell bodies of these neurons that send their axons into the nucleus accumbens, they are in the ventral tegmental area. Okay? So the ventral tegmental area neurons will now fire because the nicotinic acetylcholine receptor, when it opens, will depolarize the cell membrane, okay? And that will lead to dopamine being released into the nucleus accumbens, and that's going to lead to the positive reinforcement of whatever behavior triggered that rise in dopamine, okay? So the behavior that triggered it, that was nearby it, was that you were smoking the cigarette. So that is how you get positive reinforcement of the smoking behavior. Why you will show an increase in that behavior, basically. We are just animals, basically, undergoing conditioning.